Okay, so one of the things you're going to find on Exam P and really all of your algebra exams is a lot of times you're just looking at algebra problems in disguise. So this is number 14. I've set up a couple diagrams here that should help us see exactly what we're looking for. And what makes this problem interesting or unique is that of our coverages here, coverage A, B, and C, you can only choose either A and B, or B and C, or A and C. You can't choose only A, or only B, or only C. And then we want to know how many didn't choose any coverage at all. So it's either two coverages or no coverages. So what that means is that A alone or C alone, all of this area in here, that has got to be equal to 0. You can't choose A, B, or C on its own, so we're just going to blot that out of the graph. Same with the triple intersection. You cannot choose 3 coverages. So we really are only looking at these intersections here, and then we want to know how many chose no coverages, so I'm just going to identify those with variables. We'll call Q no coverages, and then we'll do X, Y, and Z for the intersections. That's where all of our probability lies. Okay, now let's look over here at this chart. So first we're going to blot out A intersect A, or A alone, 0, same with B alone, same with C alone. And now we can find our total. The 1/4 value that we're given for A is going to be composed of the intersection of A with B and A with C. So just like here, A with B, A with C, X and Y. And then A with B is X, B with C, we're calling that Z, and then A with C, we've got that as Y, and B with C, we've got that as Z. So from here, we're going to write equations. I think you could jump straight to the equation step, but I just thought this was a good intermediary. Certainly helped me as I was thinking through the problem. So we have X plus Y is equal to 1/4. We have X plus Z is equal to 1/3. And we have Y plus Z is equal to 5/12. So 3 equations, 3 variables, we're in good shape. What I'm going to do is solve both of these 2 equations for Y and for Z, and then substitute into this 3rd equation here. So subtract X from both sides. Y is 1/4 minus X. Solving for Z here, so subtract X from both sides. Z is 1/3 minus X. And then substituting here, our value for Y, 1/4 minus X, and our value for Z, 1/3 minus X, equals 5/12. And then from here, it's just algebra. 1/4 plus 1/3, TI30XS is great. That's going to be 7/12. Minus 2x is equal to 5/12. Subtract 7/12 from both sides. You get negative 2x equals negative 2/12. So x is equal to 1/12. This is great. We've solved for x. Plug in here. Y, 1/4 minus 1/12 is 1/3 if I recall, but fractions on the fly are not my strong suit. 1/6. So we plug in 1/12, 1/4 minus 1/12 is 1/6, and then we'll do the same thing for Z. 1/3 minus 1/12 is equal to 1/4. Even better. So we've got a value for Y, a value for Z, a value for X. We know that the sum total of our area is X, Y, Z, and Q. So 1 minus these 3 values will get me everything that is outside the circles. 1 minus 1/6 minus 1/4 minus 1/12 is equal to 1/2. So the correct answer here is C.